So we have question number 51, which says that an open vessel at 27 degrees Celsius is heated until 3/5 of air in it is expelled. Assuming the volume of the vessel constant, the temperature up to which the vessel was heated is. So according to the ideal gas equation, you have that is PV is equal to nRT. ठीक है, अब आपको यहाँ पे दिया है open vessel, which means pressure will be constant, and you have also been given that assume the volume of the vessel is constant. So the only variable here is number of moles and temperature. So we can write it like this: N1 T1 is equal to N2 T2. I hope this is clear to you. And the initial temperature is 27 degrees Celsius. So convert this into Kelvin, it will be 300 Kelvin. And the final moles. So you have been given that 3/5 of air in it is expelled, which means N2 will be equal to N1 minus 3/5 of N1. ठीक है? Into T2, which is the final temperature that you have to calculate. So it will be N1 into 300 is equal to 2/5 into N1 into T2. So T2 will be equal to 1500 divided by 2, which is equal to 750 Kelvin. So which means the temperature up to which the vessel was heated is 750 Kelvin. So option number 1 will be the correct answer. So moving on to the next one now. So we have question number 52, which says that the standard enthalpies of formation of CO2 gas, H2O liquid and C2H4 gas are respectively. So you have to calculate the standard enthalpy of combustion of ethylene gas. So what is the formula of ethylene gas? You have C2H4. ठीक है? So on combustion, it will produce CO2 gas and water, and this you have to calculate the standard enthalpy of combustion. So water will be in the liquid form. So first of all, balance this equation. It will be 2 CO2 and here it will be 2 water molecule, and the oxygen will be equal to 3 O2. Fine. So in this case the delta H combustion will be equal to summation of delta H formation of products minus summation of delta H formation of reactants. So in the products we have CO2 and water, so it will be 2 into delta H formation of carbon dioxide, which is equal to minus 393.5. ठीक है, plus 2 into delta H formation of water liquid, so it is minus 241.8. Minus delta H formation of reactants. In the reactants we have ethylene gas and O2 gas, and for ethylene you have been given 52.3, so it is 52.3, and delta H formation of O2 gas is 0 because it is the natural state. So if you calculate this, your answer will come out to be minus of 1322.9 kilojoule per mole. Fine. So option number 2 will be the correct answer. So moving on to the next one now, we have question number 53, which says that 1 mole of a substance A on reacting with excess of water gives 2 moles of readily combustible gas and an alkaline solution. So if alkaline solution gives white turbidity with CO2, then A is. So students, आपको यहाँ से hint मिलेगा, which is white turbidity with CO2. So which is the compound that gives white turbidity? That is calcium carbonate. ठीक है? And which is formed by the reaction of CO2. So it must be calcium hydroxide, because it is the alkaline solution. And now calcium hydroxide is formed by the reaction of 1 mole of substance A with excess of water. So it can be hydride because we are also getting 2 moles of readily combustible gas. So it must be calcium hydride which on reaction with water forms calcium hydroxide plus 2 moles of hydrogen, which is the combustible gas. Fine. So the compound A is calcium hydride. So option number 1 will be the correct answer. So moving on to the next one now, we have question number 54, which says that the commonly used reagent to remove the hardness of water is. So first of all, what do you mean by the hardness of water? So hardness of water is of two types. One is temporary hardness and another one is permanent hardness. So temporary hardness किसकी वजह से होती है? It is due to the presence of magnesium and calcium hydrogen carbonates. Fine. And the permanent hardness is caused due to the soluble salts of magnesium and calcium, but in the form of chlorides and sulfates. So the most commonly used reagent to remove the permanent hardness of water is sodium carbonate. So what happens is that the sodium carbonate reacts with chlorides as well as sulfates. And here M can be magnesium or calcium. So it forms insoluble salt, that is carbonate. So due to the formation of insoluble metal carbonate, we can remove the hardness of water. So option number 2 will be the correct answer. So moving on to the next one now, we have question number 55, which says that a cross-linked polymer of silicon can be obtained by the hydrolysis of. Fine. So in the first case, we have R2 SiCl2. Fine. So on hydrolysis, it forms SiR and here OH. Okay. So it can undergo polymerization. So on polymerization, it forms a straight chain polymer like this. Fine. So this is a straight chain polymer, not a cross-linked polymer. And the second case we have RSiCl3. So on hydrolysis, Cl will be replaced by OH. And on polymerization, it forms a cross-linked polymer like this. This is SiOO. So we have SiO-Si linkage. So this is a cross-linked polymer. Fine. And now in the third case, we have R4Si. So here no Cl is present, which can be replaced by OH. So this cannot form a polymer. Now we have R3SiCl. So in the fourth one we have R3SiCl. So which on hydrolysis, Cl will be replaced by OH. So which further reacts with another molecule and will form this kind of structure. And now this further cannot be polymerized. So cross-linked polymer is only formed in the case of second one, that is RSiCl3. So option number 2 will be the correct answer. Fine. So moving on to the next one now, we have question number 56.